in some cases, well, not all, you can even do that in the user space. So that makes your logs untrustworthy, right? So we take a completely different approach. You recall the figure that I just showed you, the way log entries are collected, and take a look at this one. So instead of doing the logging in the system, I do the system call interception and logging and the storage of logging outside the system I'm monitoring. So how do you achieve that? You have to so now, of course, the thing is that this is enabled by this virtual machine technology. So instead of running your software in a real physical machine, I run it in a virtual machine, right? Virtual machine is a all software-based entity. So basically, you can create multiple virtual machines on top of the same physical machine. So the advantage of virtualization is that it gives you the opportunity to monitor these virtual machines from outside the virtual machine. So you can see that the interception of system call happens on what we call the system virtualization path, right? And the system virtualization path is completely independent of the virtual machine that is being supported, right? Once you intercept the system call, you generate the log entry, and you don't store that log entry in the system that you are monitoring, right? That's a bad choice. Instead, you push the log entry to somewhere else. You push it to somewhere that is more trusted. In this case, it will be stored in the host domain, in that physical host domain. Of course, here we are making the assumption that the virtual machine achieves strict or high confinement. Namely, you cannot influence things that are outside the virtual machine from inside. Everything happens inside the virtual machine will be strictly confined within the virtual machine. So if you accept that assumption, then this will give you a more tamper-resistant logging mechanism. I cannot say 100% tamper-resistant, but it is definitely more tamper-resistant than the previous approach that I showed. Yeah.
You have to have a look or some kind of I/O interface to look into that virtual machine.
That's right. That's right. So that.
Wouldn't that be effective for the bad guys to?
No, because actually, once you're on the system virtualization path, the bad guys are not aware. So the bad guys are not supposed to be aware of this virtualization. Of course, I think that's a good point because so in that case, you do have to pay extra attention to the implementation of this system virtualization path to make sure that the bad guys inside the virtual machine will have no influence on the system virtualization path, or more specifically, on the implementation or data structure of the system virtualization path. Anyway, so we have done some experiments using real-world warrants. So some of the warrants are the ones we capture using our honey farm. So we just capture them from the real world, and some of them, we actually also synthesize, our own malware because we realized that some of the warrants, some of the real-world warrants are simply not malicious enough. So you want to push the envelope and and also to come up with the most unfavorable condition to test the effectiveness of the malware investigation technique. So among the warrants that we experimented, I want to just show you 3 representative set of experiments. We actually experimented with more than a dozen warrants and their variants. And for the 3 warrants, namely the lion, slapper, and SARS warrants, we are able to identify its initial breaking point before log analysis by just looking at the color of the corresponding log entry. So these 3 warrants exploit different vulnerability in different software. Lion warrant exploits the DNS server vulnerability. The slapper one exploits the web server vulnerability, and the SARS one exploits the Samba server vulnerability. So you need to identify the specific software. Then, for example, the malware investigator will go and fix or patch these respective software systems, right? And another advantage is that you will see that the percentage of log entries that I need to investigate in order to reconstruct the episode is significantly reduced. So the best performing case is the SARS one. So I only have to process 12%, slightly more than 12% of all the log entry. I was able to reconstruct, how SARS-1 infect my system, how SARS-1, install backdoors and everything by checking those 12% of the log entries with the specific color, because I can safely discard log entries bearing other colors. So I want to, of course, by now I have shown the main features or the main effect, some of the experiments demonstrating the effectiveness of process coloring or tainting. I want to kind of flip the coin, and also I want to kind of show you the other side of the technique, namely its limitations, right? So the first limitation or the first potential problem with process coloring is that, because everything now so depend on the color, right, or the tainting information. So what happens if the malware gets even smarter? Once it gets into my system, it will try to contact, different software, and so that it will get multiple colors. So when a bad thing happens, you look at the log entry, you realize that that single entry has not one but 2, 3, or 4 colors. Then you can no longer tell which one is the real breaking point, right? So that's bad. But if you think about if you think about this scenario, I was actually encouraged, because that actually gives you a additional level of anomaly detection. The thing is that if you see a log entry with multiple colors, which we call color mixing, if you see a log entry that shows this color mixing phenomena, that one, that color mixing itself is an anomaly that deserves further investigation. Because if you look at the server environment, if you, for example, for the industry infrastructure where they consolidate all the server software in one physical machine, like the web server, mail server, or whatever, I mean, they are supposed to run independently. They are running in the same system simply because of cost cutting or consolidation. So they are not supposed to talk to each other. If you see a log entry with multiple colors, that indicates that this log entry or that corresponding process is influenced by multiple applications. So that is not normal. So that gives you a hint or a lead, right? To look, to explore or to investigate further. So this is what I called a anomaly detection point. And if you recall, I mentioned that one of the problems with the existing tool is that it relies on an external detection point to trigger the malware investigation. Now, if you have this color mixing phenomena, the color mixing, it will give you more timely triggering of malware investigation, because once your system has a log entry with multiple colors, you can immediately raise an alarm saying that this is not normal. We need to go from that specific log entry and we need to trace back and see why that log entry has so many different colors. Right? And semantically, it means that this process has been influenced by multiple server applications. So you may notice that I've been focusing on the server-side environment, because I'm less confident in saying the same thing about a client-side environment. Why is that? Because in the client-side environment, applications do talk to each other, right? Because sometimes you use, for example, a Word editor to edit a file, and then you use the file, you edit your source code using an editor, and then the source code get compiled by GCC or other compiler. So you do see the interaction or influence of multiple applications on your stuff. And these are actually legal. So that's a problem. So in fact, the client-side color mixing does create some additional complexity, in uniquely identify the root cause of your malware intrusion. So the second weakness is that we kind of assume in this approach that the operating system kernel has integrity, because the operating system kernel actually performs the tainting, right? As I said, if the tainting mechanism is not trusted, then all bets are off. So in this work, we kind of assume that the tainting mechanism, which is performed by the operating system itself, is trusted, right? That is, I have to admit that this is an assumption, right? And in many cases, this assumption simply does not hold, because we also